Hello. Uh, so, we will be continuing our discussion on cloud computing. So, what we have seen that in case of cloud computing, what we are trying to do, we are trying to offload our computing and computing processes and data to the cloud, right. So, that it is maintained by a third party, and the on the other end the customer or the consumer or the user more concentrate on the business process. So, that is the basic objective of or model of the things, right. There are a lot of technicalities at the back end, but nevertheless we are offloading the things. So, what we need a very strong backbone, right, or a strong backbone network which should be always up and able to transfer data on a large volume. As we see, as along with the development and being most of the things are digitally enabled, we are getting a huge volume of data. In other sense, a huge volume of data maybe need to be transmitted from this customer end or consumer end to this cloud service provider, being executed. The results in some cases are transmitted back or transmitted in other places, right. The major issue is this huge volume of transfer of data. And what we see in recent development with number of activities, especially Internet of Things coming up, and more or less and huge variety of sensors in place. So, we have lot of multimedia data which need to be transmitted, right. And that is one part of the story, that we require a huge backbone and type of things. As far as the cloud is concerned, what we consider, it is a huge computing power, much higher than what the devices can do, and it is some sort of a infinite computing power is there. On the other hand, what we see, that a huge volume of data are being generated and being transmitted over the network. Again, what we see, that the devices, starting from, as we discussed about mobile devices, smart mobile devices or other type of devices, even intermediate network devices, what they are becoming is more powerful in terms of computation and more resourceful things. Or in other sense, we are not all the times exploiting the resources available in the things. Say consider a particular sensor node or a local sync node of a sensor, which are collecting the data and transmitting to the in the upward path, maybe to the cloud. So, this could have been done some processing at the end. Like I can say that suppose in this particular room or a particular lab, I have say 10 temperature sensors, right. So, what is my basically business model? This temperature should be varying between say 18 to 22 degree centigrade. That is the operating range of this temperature. Now, what we are doing, this all these 10 odd sensors are sending the data to the up in the server, maybe in a cloud, that is calculating whether the within the limit and type of things, and I can have say 10 such labs. So, there are 100 such data are going on, and if the temperature is varying somewhere, it is sending alert. Now, if you consider this particular a particular enclosed lab or single things, otherwise what I have could taken, I taken a local DSN whether my temperature is okay in the lab by the sync node of the sensors which are collecting this data of this particular room, and it takes a call that whether higher or upper, and then sends that say some statistical data, or what we say some aggregated data to the sensor. It may be the average, or it may be average with other standard deviation, etc., to the things. In other sense, in other than sensing this transmitting this 10 sensors data, I am sending one average data, or and which serves my purpose. Even you can say that if my sync node is intelligent enough, it can take a call that whether the temperature is within this operating range, yes or outside things, some 0, 1 or yes no type of things, and then transmit this. In other sense, this is taking some part of computing at the things. So, with the intermediate devices becoming more intelligent, whether there is a possibility of pushing the computing from logically centralized cloud to somewhere more down the line, right, towards the edge of the things, right. That is exactly what we are trying to discuss today, is what we say this sort of computing is fog or from cloud to fog, right. So, cloud is the whole thing and fog computing. So, as we see the challenges or the data what the cloud computing today is doing the processing of huge data in the data centers. Data centers may be privately hosted or publicly available by paying rent, that is it can be a public cloud or a private cloud. All necessary information has to be uploaded or transmitted to the cloud for processing and extracting knowledge of it, right. So, the whole data as we are discussing need to be transmitted to the cloud. Now, also we have seen the typical characteristics of cloud for which we are the today's world is inclined towards, is that dynamic scalability. I can scale up or scale down based on my need. So, another is that no infrastructure management or practically minimal infrastructure management at the user end. So, if I offload everything that computing etc. on the cloud, so I require very less infrastructure management at my user end. And secondly and finally, what we have a metered service, right, pay as you go model. So, these three things, the dynamic scalability, minimal management or all my infrastructure management pushing it to the cloud, and metered service pay as you go model, these are primary features of the cloud which makes it popular. There are several other things which are there, but nevertheless these are the three things which are the driving force. So, whatever we do not want to lose out of the things. If we compromise on those type of features, then the very motivation to going towards cloud may be challenged. Now, there are issues with cloud only computing. So, what we say that only the cloud is computing, rest are sitting duck are maybe the issues, especially in today's applications which variety of sensors, variety of real time operations and lot of redundant data, right. There are lot of data which are redundant, like if I am sending temperature things, it may be meaningless to send all the sensors data which are more or less same information, unless there is a different in some sensor data, I may not want to send the data. All are reporting between around 20 degrees centigrade, it does not require a cloud to take a call, it could have been done at a much lower level. So, that or in other sense I have a huge amount of digital data to be transmitted. So, communication takes a long time due to human smartphone interaction and type of things. If the data centers are centralized, right, data centers are in some portion. So, all the data from different region can cause congestion in the core, right. So, being transmitted things, especially in case of exigencies where lot of volumes of data suddenly pushed into the thing, right. In case of say some disaster or some huge amount of influx due to some event, this is a lot of volume of data suddenly influx, there is a huge volume of data to be transmitted and there can be congestion, and such a task requires very low response time to prevent further crash etc. So, if I have this sort of things which has some sort of accident, some accident prevention mechanisms should be activated. So, where we require a very low response time, so immediately need to be acted. So, waiting for that cloud to take a call, revert back and all those things may take lot of time. So, that is another problem. So, the emergence of a concept called fog computing. So, on the cloud we are talking about fog, that is little bit bringing ground to the ground, or in other sense we are pushing this computing thing from the centralized data center or the cloud data centers to these edges, right, or intermediate or the edges of the network, edge of the network. So, fog computing, also known as fogging and edge computing, though Some people have little other views of that edge computing, but nevertheless it is a fogging or edge computing. It is a model in which data, process, applications are concentrated in devices at the network edge rather than existing almost entirely on the cloud. So, now not only the cloud at the centralized things, the data, application and processes are distributed in the edge, right, which some effect of some way of distributing this whole processing where the things. What it helps us? It helps us in reducing the data load in the communication. I can have a local decision and which is not needed for the global type of things. They say smart traffic light management system. The traffic light management system in Kolkata is nothing to do with the traffic light management system in Delhi apparently, right, for day to day traffic management, right. So, I could have done it locally, or even I can say that a region of a particular city may have only aggregated data which need to be transmitted at the higher level for traffic management, right. So, that basic intermediate management could be done locally. So, those things could be done in a concept of what we say fogging or fog computing. The term fog computing was first introduced by Cisco as a new model to ease wireless data transfer to distributed devices in the Internet of Things network paradigm. So, as IoT is becoming omnipresent or IoT is becoming everywhere, it is there Internet of Things. So, its huge volume of data, devices which much computing capability or resources, much higher resources, can do a bit of a job which could have been solved at a lower level. So, Cisco's vision, if we look at that, fog computing is to enable application on billions of connected devices to run directly on the network edge. Since Cisco is primarily a network driven organization, so it has a huge number of devices across the world and those devices are somewhat managed etc., managed by some sort of a homogeneity is there because of from the one make, and there are resourceful devices which could have done some sort of computing things, and I can even run applications on the devices and doing so and so forth, right. So, user can develop, manage, run software application on Cisco framework of network devices including hardened routers, switches etc. Cisco brings a open source Linux and network operating system together in a single network devices. So, it helped to do not only computing, but because if you want to do computing you need to give some sort of a platform to run the applications for the computing things, right. So, those things are there in the devices and this is possible because of there are resources available at different layer of the network towards the edge. So, if we look at a view, so this cloud at the top, it is still there and it should be there. There are intermediate devices which were now helping only so far was only transmitting the data. Now, can they do some sort of a computing, what we say fog computing, and there are end user devices which are spread over different locations, starting from say smart vehicles or which can communicate, devices, servers, smart cameras and anything which can do, right, any device which can capture digital data, compute and transmit, right. So, bringing intelligence down from cloud closer to the end user or the edge of the network, that is one of the thing. Cellular base station, network routers, Wi-Fi gateways will be capable of running these applications, right. So, there are, because whenever I communication we have cellular networks, Wi-Fi router into place, and if those are having surplus resources they are able to do that. So, that my application can run, say I want to run a application for monitoring the environment of different labs starting from temperature to humidity, maybe some sort of a what sort of air pollution or air content etc. So, this sort of things can be done. End devices like sensors are able to perform basic data processing, right. So, the sensors can do a basic data processing. Processing close to the devices lowers the response time, enabling real time applications, right. So, whenever we process close to the devices, so the response time reduces, that is obvious, and I can do lot of real time processing of the things, right. So, I can do a real time processing of a say of any applications, like I do a application based on that what we say dynamic signaling mechanism of a traffic light based on the traffic on the road. So, the cameras which are on the road capturing that how many what is the traffic flow, based on that the traffic light signaling may change, if that is the need of this traffic management. So, that is local, right, local to a particular portion, local to a region, local to a city, right. So, that definition of locality may vary from application to application, but what we require that your devices like the traffic light device etc., should be able to run this application which can take a call, right. So, those are things. Nevertheless, this is about the fog. So, if we look at fog computing enables some transactions and resources at the edge of the cloud rather than establishing channels for the cloud storage and utilization. So, rather than just transmitting, it do some sort of a transaction processing or application running on the things. Fog computing reduces the need of bandwidth by not sending every bit of information to the cloud channels over the cloud channel, instead aggregating at a certain access point. So, it aggregates and send the aggregate data. This kind of distributed strategy may help in lowering cost and improve efficiency. So, this sort of it is a distributed strategy, and this type of distributed phenomena may help us in lowering the overall cost, not only in terms of monetary, it the cost of transmission in terms of time etc., and we can do efficiency, right. I can run several applications which can be real time and type of things. So, this motivation is obvious already, whatever we have discussed the motivation, the fog computing paradigm that extends cloud and its services to the edge of the network. Fog provides data, compute, storage, application services to the end user. If you see, it is some sort of a small form of a instance of the cloud for that local type of things, right. So, it is a doing some sort of a computing or giving some sort of a cloud service at that time at that portion of that region. Recent and there is another side of the things, because we have several series of developments. One is the smart grid, other is the smart traffic lighting in cities, especially cities, connected vehicles or strong vehicular networks which is coming up, and also the software defined network. So, these are the different aspects which are itself is a topic to work at, but the smart grid, smart traffic lighting, smart vehicles, software defined network and so on and so forth, they are becoming pretty popular, and in turn they generate huge volume of data, right. Everyone is generating huge volume of data which are being transmitted at the higher up in the layer for doing that. So, all these different aspects has motivated or what it has pushed the processing towards doing it at the edges or intermediate layer rather than pushing everything to the cloud. So, this is what we look at the fog. So, this is the same thing what we discussed. So, we have one in this cloud, so which has a data center with huge capability, massive parallel data processing, big data management, big data mining, machine learning algorithms etc. So, which is there and should be there. Intermediate layer which is more near to this edge or the devices. So, they can act as a fog. So, there can be fog sites with real time data processing, data caching, computation of offloading and those type of things. So, these are not so powerful as that, but as such they are intermediate devices which are used for transmitting data. So, this can be used at the end or at the front end or the edge or the last mile. What we say, what we have the sensors, we are collecting different type of data, perform data pre-processing and compression. Mobile device serve as a human computer interfaces, like these are the different type of things which are transmitting out here and in turn transmitting to the things. So, this some sort of communication, if you see that both way arrow, can be taken a call at this end itself, right, without transmitting the whole data at the things. It may be some sort of aggregated reporting and type of things, or aggregating the data and putting it to the cloud for running some intelligent algorithm and machine learning based algorithm and type of things. So, we have more interactive and more responsive end to more computing power and more storage end at the other end. So, instead of just putting a channel to transmit everything to the cloud and compute and come back, we are doing some provisioning of intermediate processing for to serve the application based. So, this is definitely a major motivation. And what we try to look at, that as we have seen that the typical properties of cloud, that having infinite scalability, theoretically, or quote unquote infinite scalability, or offloading, or having infrastructure, no need of maintaining infrastructure at the client end, or metered services, those need to be preserved or respected, right, in case of a fog, and those are definitely are still there as what we have discussed. So, there are fog computing, there are several enablers, as those are true for our cloud computing also. One is that virtualization. So, virtual machines can be used as the edge devices, right. So, there can be virtual machines. Containers or container services reduces the overhead of resource management by using lightweight virtualization, or what we say container based application or services. One of the popular container is Docker container, right. So, the idea is it docks into that particular things and run on the thing. So, you do not have to, that dependencies is carries along with the thing, right. So, it is again a separate topic, if possible we will discuss sometime, but that is this docking or container services are becoming very popular. So, that is another enabling technology out here. Service oriented architecture, as we have discussed, which is a enabling technology for cloud also, is here also. That SOA is a style of software design where services are provided to the other components by application component through a communication protocol and other things. So, we have a service oriented architecture with three major component of service provider, service consumer and service registry. So, that heterogeneous loosely coupled parties can talk to each other, right. So, SOA architecture is one of the driving enabling technology, and also what we are seeing at is a software defined network, right, SDN. So, SDN is an approach of using open protocols like for example, OpenFlow to apply globally aware software control at the edges of the network to access network switches, routers that are typically would use closed and proprietary firmware. So, this is another technology which is becoming pretty popular or already popular in software defined network, and which is enabling technology for our fog also. So, with this several enabling technology, fog is becoming a reality and being deployed and used in several cases. So, in looking at, we should not see that fog as a replacement of cloud. It is not a replacement of cloud, not neither a competitor in that sense, right. It is basically offloading some of these workload from the cloud to this edge devices, because the resources are available, because there are applications which are real time and needs more quick responses, and overall process may be cost effective and efficient. So, fog edge devices are there to help cloud data centers to better response time for real time applications, right. Handshaking among fog and cloud is needed. Appropriate handshaking or synchronization between this fog and cloud is very much needed. Broadly, benefits of cloud computing can be that low latency and location awareness. So, it is aware that which location is operating, widespread geographical distribution, especially with the sensors etc. So, it has a thing. Mobility, that is another important thing, like nowadays devices are, we have lot of mobile devices, right. So, the distance from the cloud or the intermediate devices which say end device passing through the intermediate devices will change based on the mobility of the things. Now, this required a resynchronization, re-establishment of the path. Had it been in a locally somewhere, it may ease the computing and response time. So, low latency and location awareness, widespread this mobility, very large number of nodes with, as we are discussing with sensors and things, predominant role of wireless access, right, huge volume of wireless accesses, strong presence of streaming and real time applications. So, these days we are having a huge streaming and real time applications, and which requires quick response time, huge volume of data and type of things need to be processed quickly and may not require all data to be transmitted, right. So, this huge volume of data can be locally processed and aggregated data can be transmitted, so that the overall response time improves in a considerable way. Strong presence of streaming and real time and heterogeneity, different sort of devices, different type of makes and inherently heterogeneous. So, I can have some sort of a fog sort of intermediate framework which basically talk to some devices which may be different from other devices. Like I have a group of sensors, I have a their sync node which talks to the sensor, also do this aggregation, which may be different than other set of sensors which has a different sync node, but nevertheless when they do this aggregated data, that is in a more standardized format. So, I can handle heterogeneous devices. So, advantage is already we have already discussed. So, can be distinguished from cloud by proximity to the end user, that is one of the advantage or over this vis-a-vis cloud. Dense geographical distribution and its support for mobility, right. So, we can have instead of centralized, I can have lot of distribution. It provides low latency, low awareness and improves quality of service and real time applications, right. So, there is a chance of better performing the things. Rather, we try to look at it is not isolated fog, but for cloud as a whole can give a better service to these consumers, right, in terms of cost, in terms of scalability, in terms of your efficiency and type of things, especially applications where we have high quality of services and real time services, streaming videos and type of things. There are of course some issues related to security. So, one is that as devices are dispersed, right. So, maintainability of the security protocols at different fog devices is a serious challenge, right. So, it is at different location. Now, had it been cloud, you have a provider at a particular centralized things, you can put lot of security mechanism in the place, but if you once you distribute over the fog, then you have to maintain so many things on different edge devices. So, it is not only the data processing etc. So, there can be security issues. So, and man in the middle attack type of things can happen. So, as devices are dispersed, as this computing data are being there in different edge devices. So, there is a issue of things of man in the middle attack can be there. There are issues of privacy issues as same that it is being processed at different edges and whether the data leakage is there. then whether you know about the things like if I consider smart grid or connected vehicles. So, if you do the intermediate processing, whether you are basically tracking the vehicle or looking at the processing of the consumption of an individual house or home and type of utilization, those can be there. Like in case of a smart grid, smart meter installed at the consumer home, each smart meter and smart appliance has an IP address. A malicious user can either tamper with its own smart meter, report false reading or spoof IP addresses and so on and so forth. So, whatever it comes with typical network security related issues may also come may also be problem out here. So, maybe a challenge. So, there are definitely security issues, there are security issues in the cloud, but this extend that to much more things as you have different devices are activated. So, what we see today that this fog is just not an extension of the cloud, it is a necessity based on the different application, huge volume of data and the devices, intermediate devices becoming more resourceful, right, and they are capable to do this type of means computation. And secondly, in order to in doing so, I may not be doing all this high profile computation, but we can basically do some sort of a aggregation of the informations and sending only the aggregated informations, which lowers the basic bandwidth requirement, intermediate bandwidth requirement, also lowers the data load at the cloud end. So, what we see, it is a technology which is a need of the hour, and especially with IoTs and other things coming in a big way. So, with this we will stop today. Thank you.